Okay, now that we're done with all of those ones, we can go on to the challenge question. There was a lot in that exercise. Okay, so, challenge. Okay, find the possible values of k. Find k where, for the quadratic equation, 2k x squared plus 5k x plus 5k minus 3 equals 0. And it had to have real roots. So, something like that looks like it should have many, many solutions, and it's got to have real roots. So, looking at the discriminant of it, okay, we are looking at b squared minus 4ac. Now, if it's greater than 0, it has 2 real solutions, and if it's also equal to 0, it has 1 real solution, which is equally acceptable in this case. Okay, so what are my values of a, b, and c? Okay, a is equal to 2k, b is equal to 5k, and c is equal to 5k minus 3. So, putting that in then, we have got 5k squared minus 4 times a, which is 2k, times c, which is 5k minus 3, and that is all greater than or equal to 0. Right then, 25k squared minus 8k times 5k minus 3. If I take a k out, I've got 25k minus 8 greater than 0. Okay. Okay, and now multiply that out, so we end up with 25k squared minus 40k squared plus 3 is 24k. Is that everything? I think so. Greater than less than 0. So 25 minus 40. Minus 15. Okay. So k minus 15k plus 24 greater than or equal to 0. Okay, so we've got the option of k is greater than or equal to 0, and we've also got minus 15k is greater than or less than minus 24, which means k is less than or greater than 24 divided by 15, which is 8/5. 1 3/5. Okay, so k is greater than 0 is less than 1 3/5. Okay, so less than or equal to k, less than or equal to 8/5. Okay. Right then, final one of this chapter, question 2. A straight line has an equation of y is equal to 2x minus k. And a parabola has an equation of y equals 3x squared plus 2kx plus 5 where k is constants. Find the range of values for which the line and the parabola do not intersect. Okay. So noting the do not intersect. So what are we looking at here? We've obviously got a line that's shooting up at a 2x angle like this, and we've got a 3xk squared, which is doing a big U like this. Okay, and so clearly we must be able to get a k that moves it so that they do not intersect. So if we find out where they do intersect and only have one solution, in fact, we can put it together and find out where it only has unreal solutions. So let's put both of these together to begin with. Okay, so we can do 3x squared plus 2kx plus 5 is equal to 2x minus k. Quickly put this all equal to 0. 3x squared, what was that? That was plus 2kx minus 2x plus 5 plus k. So when we factorize out these two terms here for an x, we end up with 2k minus 2. Okay, so a is equal to 3, b is equal to 2k minus 2, and c is equal to 5 plus k. So we're going to use the discriminant again, b squared minus 4ac, and we want to choose the discriminant that is less than 0, so it doesn't actually have any real solutions. Okay, so 2k minus 2 squared minus 4 times 3 times c, 5 plus k, needs to be less than 0. Okay, 4k squared minus 8k plus 4 for the squaring out of the brackets, minus 12 minus 60 minus 44k, no, 12k. Is less than 0. 4k squared minus 20k minus 56 is less than 0. Okay, solving that straight onto the calculator with it, I think, for the solving of the polynomial. Okay, and we've got coefficients of 4, minus 20, and minus 56. And we have a k is equal to 7, and k is equal to minus 2. So the range of values is minus 2 is less than k is less than 7, I believe. And if we have them equal, they just come in there. Okay, so less than equal to. Okay, that is it. We are allowed an equals on this all the way down that I just sneakily added in, because at the point where this parabola and line touch, they do not intersect, they touch, and that is where it has one real solution, which gives you the equal to 0. Everything after that is into imagined solutions. Okay, so minus 2 is k is greater than minus 2 and less than the 7 with